Okay, good morning. I'm very sorry. I'm fixing something. Okay. I think last time we have discussed about the plot command. Okay. Now, uh, there are some data that the range is too much or is very big. Big. Okay. And using a linear plot like the plot command that we have, um, makes you not see anything from it. That's why we sometimes we use a logarithmic scale for the x or the y axis. Okay, so this is used to show a very large range of data. Example, frequency response. Okay, if we are talking about frequency of communication system, we're talking about megahertz, gigahertz range. So that's million data points. Okay. Now, putting that on a linear plot makes it not very clear. Okay. So that's why we could just make the plots logarithmic. Okay. So there are three types: semilog x, semilog y, and then log log. Semilog x basically it gets the it takes the logarithmic plot on the x-axis, semilog y on the y-axis, and then log log is on the both axis. Log log is not that much use compared to semilog x and semilog y because there are many applications in electrical engineering in our field that uses a very large range of values. For example, let's have this x is equal to minus 10, the change of 1, 10. And then y is equal to, so we'll just get the e raised to x cube of that y. If we plot, if we plot xy, basically we could not see anything. Okay, it's just a straight line. Okay, so we would not have an idea of what really is happening. As you can see here, so the last value at 10 x is equal to 10 is very high. But if we as you can see, the range from for y is 10 to the 305. So that's a very large scale. But if we try to make it semilog y, you can see that it's tapering out. Okay, there is a certain point that it is almost non-changing. So that's in the vicinity of 1. Okay, but it immediately increase or decrease in value. Okay, as you can see, it will have this plot. Okay, now how do we manipulate uh, 2D plots? Okay, so we over how how to use hold. Okay, hold means here is if you want to display several plots at the same time, okay, you must use the hold command. So hold on. So for example, you have a figure. Okay, this one. Let's plot it again. Plot. And then if we type in again semilog, so what happens is uh, it will overwrite the figure. But if we hold the figure, so let's say hold, and then we plot xy, so they will be plotted together. Okay? But since they are the same data, you cannot see it. Uh, CLF is clear figure, by the way. Okay. So hold off, hold on. So uh let's try to see it. I want to plot sine x and I want it to be color red. Okay, so it looks like this. Okay, if I hold it on, so hold on. So, as you can see, if you put on, it will no longer give you some data, some message or current plant release. So basically, we type hold off there. So hold on again. So I'm holding on the plots. So let's plot this one. So if I plot this, instead of overwriting the plot, what it will do is it will put the plot there. And then if we type another plot again, it will give you 3 plots. Okay, and then hold off. So that when you plot again, it will overwrite. Okay, so that's the hold mechanism. Now let's take a look at the plot YY function. So the plot YY, so uh, let me just copy the data. I have here x1, x2, x1, y1, and then x2, y2. Now, if I use the regular plot, so let's say I use this plot, it will give me 2 plots, right? Now, uh, as you can see, only the green line has some useful data. Okay? It looks like the blue one. Well, it seems like it's kind of wavy. Okay, but as you can see, since the green line and the blue line don't have the same x-axis, okay? So what MATLAB did here is it fits both of them, okay, so that we can see, or we could have the best view of the data. Now the problem there is since the y-axis for the green one and the y-axis for the blue one is pretty much very limited. Okay. Um, no, the blue one is limited. The green one is very large. So what happened is we could not see any details on our blue one. Okay. So let's try to put that down. Okay. Now, what if okay, I use plot YY? So plot YY, what happens here is instead of you having one axis, you can get two axes, two y axis, so that you can see both of the data. So if we plot YY, you can see. So we have a y axis for the blue line and then a y axis for the orange line. And compared to the previous plot, okay, so let's compare. Let's compare to, to plot. Comparing the two, okay, although you get the data from you get an insight for the green line, we did not get a proper insight on the blue line. But here, as you can see, there is quite a large oscillation. Okay? So, but take note, you can only use plot YY for two data. Ha? So we could not use it for more than two data. Okay, so this is using plot YY. And then I do have a note here. When you plot this, the y-axis values are not of the same range. Okay, unfortunately, it does not allow change in color of type. Okay, and y label only affects the label on the right axis. Okay, but you can do it programmatically. Okay, now let us have this uh, programmatically. So the problem here with plot YY, the problem with plot YY here is we don't know. Okay, we can uh, edit out the label for both of the axes. Now, the good thing is we have the access handles, okay, for our command. Okay, so actually, when you plot YY, there are properties on the figure that's not written in the workspace, but we want to know that property. So let us have this code. So plot YY, it gives you different output argument. In this case, I would like to get the uh, x and y axis handle. I want to get the detail for the first line and then the second line. So since it has two lines, okay, and then I do plot YY. You can do that if you save out plot command. It's also the same. Here, as you can see, I do have an access handle, a line 1 handle, and a line 2 handle. Now, these are the properties of that handle. Now, you can set that. Let us set our line 1 handle. Line 1 handle. In this case, I want to change its line style. Okay. I want to change the line style into uh, uh this one. And then I want to change its color. So again, color into there's no autocomplete because there are many choices. Actually, you can put RGB value there. So I want the line handle one. So this is the first line, this one, to be blue. So if we do that, the line handle will become blue. But take note, only the line handle became blue, not the axis. Okay, so let's change the style of line handle to line 2 handle. Line style, I want it to be dash and color green. Now it became green. Okay, and if you put it title, okay, so you have the title. Now let us take a look at access. Oh, I'm getting the access handles of I'm getting the first axis here. Okay, I'm getting the properties of that access handle. So as you can see here, okay, so I just copied the access handles of whatever is in access handles 1. Okay, and then Now, I told it that I want my access handle to be the first handle, and then I want to get the Y label. So this is a Y label. Really, you can choose not to do that. Okay, because Y label automatically only works for the left one. But for the right one, so let's call the right one. So I'm calling the right one now. That's my present handle. So it will be highlighted here. And then let's put a Y label. So it will give you the label at the Y axis. Okay? And then just X label. And then we have our, so it works on the first access handle. Okay. So that's how you programmatically change the properties of a plot. Okay. Instead of doing, let's say, plot uh, X, Y, and then you have here line, style, like that. Okay. So we can just get the property outside and then change it along the way. Okay. So now we have this access command. So access command is used to fit our plots. Okay, we have axis square. So axis square, it means the x and y axis are forced to have a square dimension even if they are not equal. Axis equal, they are we are forcing a unit spacing that would be equal. Okay, you'll say later on. Axis ij, it puts the origin to the upper left. Axis xy, the regular plane, lower left. Okay, and then axis type. So if you have a very what do you call this? If you have very loose data, okay. So what axis type will do is it will decide for the uh, proper range that it will display. Axis up, it will remove all the axis labels and so on. Axis on, it will bring it back. Okay. So we have the command function duality in MATLAB. There are several command and functions that are used with each other. Okay? Or that can be used as a command or as a function. For example, axis. Axis is a command. If you want it uh, to create a square axis, so axis is square. But if it's a function, you must put in an argument before. Okay? But the good thing about the command form is you can put several of it inside. So, for example, you want an axis equal and then axis type. So you just put in axis equal and then type. Let's try this and then you'll see uh, how important that axis is. Okay. So I'll have an x and then an exponential y. So let us plot x, y. This is our xy. Okay. I just put a label. Let's label x and then y label y. Okay. Now, what can we see here? What what we can infer from this graph is that it seems like the graph is 0 for a very, very long range. Okay. Now, what we can do, okay, so is maybe zoom it out. In this case, I will zoom it out using the access command. I only want to see the range from -10 to 3 on the x-axis and then -6 to 7 on the y-axis. Why do I want to do that? Okay. I'd like only to see this part, around this part here. I like to zoom it out. So if you do axis and then coordinates, so this is x from 10 -10 to 3. So it's around here from -10 to 3. So as you can see, this is where it's only 0. And then I only want to see -6. So from this point, no, not this point. So around here, I only want to see a very, very small portion of it. Now, if we do that, as you can see, it's really not 0. So it is changing. Okay. Sometimes you need to look at the graph properly. So access command will help you see those things. You can just zoom it out programmatically. Okay. Now, if you use the variable for axis, so for example, uh, you want to have your axis data, or you want to know the range of the x and y axis, and then the um sorry, yeah, the x and the y axis. So it will give you a 4 value. So it is composed of the lower x, higher x, lower y, upper y. Okay. So for example here, I have here a plot, right? Now I want to get the limits of that axis. So I'm getting the data from there. So as you can see, it gives me out, it's from 0 to 16, okay? And then from -8, so here, to +8, okay? Now, let's say I have some desired value, desired x and desired y. Huh? I have a desired x and then a desired y. So you want to change it, you want to customize the range, right? Now, if I do axis, okay, you want uh you want still to retain the desired the original axis lower limit, but you only want to change the upper limit. So this is how you do it. So in this case, I have this axis. I put it in axis limits. The first one, this is the first one, and then I have a desired maximum x, and then the next one is the minimum of y. So it's in the axis limits. It's the third one, and then a desired maximum y is our required y. And if you type it out, as you can see here, what happens is the axis will change. Okay, so if you need uh to show it in a different manner, and if you put it out in a new variable, it will give you minus 10 to 0, 10, minus 8, and then 15. Okay. So, axis, earlier we showed you how to use hold on to create multiple plots at the same time. Okay. Now, if you use those command, so MATLAB will automatically readjust the limits for you. So in order for you to do that, we just have to uh, retype, okay, your limit the way you want it. Okay. For example, I have here, actually this is, I will not tell you what this is. But if you know analytic geometry, you are probably familiar with this one. So plot, so I'll try to plot XY here. Okay. So it's in there. Oh, sorry. I have a figure window. What did they say? Open a figure window, resize the window so that it is rectangular. Okay. I want to make it rectangular. So in this case, I want to make it this way. Okay. So plot XY. So if I plot XY, or I want to make it this way, I like to make it, I'll make it longer instead of wider instead of longer. Okay. Uh, so if I plot XY, you will see I have an oval plot. Okay. The question is it really an oval plot? Now let me change the axis. I want the axis to be from -5 to 5 and then -5 to 5. It looks like an oval plot, but the problem here is it's obvious that it probably is not giving us the proper shape. Why? Because as you can see, this is from this, it's the same from -5 to 5, right? Now here, uh, this -5 to 5 is way longer than this. Okay. Now what we can do is, obviously, we want to make it a square first. So I want to make it a square. So as you can see, oh, if it's a square now, and then you'll see it's a plot of a circle. Actually, x is equal to 2 cosine theta, r sine theta, and y is equal to x is equal to 2 cosine theta, and y is equal to r sine theta. That's a plot of a circle parametrically. Now, since we use the axis square, we were able to show the proper shape of our plot. Okay. Now let us try to plot an ellipse. So let me put in the ellipse. This is the ellipse. So it's almost the same as a circle, but they should have different value. If we plot xy, plot xy, it's an ellipse. Okay. The problem is it correct? Is the ratio correct? Okay. Now let us make it square first. So this is now if we made it as axis square, as you can see, it just made the x and y axis the same length. But as you can see, it's really not the same length because we have -2 to 2 and the x, and then -4 to 4 on the y. Okay. Now, what I want to do is make it equal. So axis equal. If you do that, so as you can see, I made the axis to have equal range. Okay. Now, but the problem here is there's too much space. Okay, being used. Since we made it equal, too much space or are wasted. But if we put in axis type, it will fit it for you using equal spacing because you have equalized it before. Now, let's try axis ij. Okay, where is 0, 0? So if we fill in axis ij, as you can see, what happens here is instead of -4 here, it went there. Okay. So if you use the ij command, so the origin will change. It will be on the other direction. But if you put in axis xy, this is the regular one. Okay. So from -4 to 4. Okay. And if we bring axis normal, so this is the default form. So that's the axis command. I think there's, yeah. Now, let's try this one, a gtext function. So gtext, if you want to put in some comment in your data, a gtext is what you can use. Okay, so let's plot ty. Let's plot ty. Okay. I want to put in grid on, and then x label, x label, x label, right? Okay. And then let's put in a title, plot of sine 2 pi t plus t 0. Okay. Oh, I forgot. Uh, and then I want to put in gtext. Gtext is text was placed with gtext. Okay. Now, if you put in if you key in this command gtext, what happens is it will help you provide something. Let's say if you want to put in a text somewhere in your plot, and then you use command gtext. Okay. So what happens there, if you enter it, and if you go in your figure, there will be a crosshair. See, yeah, that crosshair is where it's telling you that this is where you will place your text. Okay, why do we want to place text? Sometimes we want to emphasize something in our plot. Okay, so we'll use maybe we'll use gtext. Okay, so if we have it and crosshair and then click on it, so this place was text with gtext. So again, gtext, say I, so it will give you that that point. Say other thing. Most of the time you want to emphasize your work, our work. Say, this is our work. Let's say this is our work. Okay, so that is gtext. Okay, the problem with that is you are very much in control and only looking at the plot. Now, what we want to do is specifically put it on a very, very specific identified point. So we'll use the text function. So let's say I have this graph, plot xy. So let's see, where's that? So this is our plot. Now, I am interested in getting the maximum. Okay? I want to highlight the maximum point. Okay, so we have this. I want to highlight the maximum point. So in this case, let's manipulate the graph. I want to turn on the grid, and then I want to change the axis. So as you can see, we could not properly see, we could not find anything at the top here. So let's make the y-axis larger. So axis, I want to retain the x-axis minus 2 to 2, but I want to just see the minus 5 to 5 of the y-axis. So we have space here now to put in something. If you put gtext, we are not very, very specific on it. Okay. Now, I want to get the maximum of y. So in this case, I want to get the maximum of y. And where is it? So I just put in y index. So it's 2 argument. Normally, max will give you, it will give you, no, normally you only use the first output argument. So if by default, you only use one output argument, it will give you the maximum of y. Now, in this case, max y, okay, will give you 2 arguments because you asked for it. So one is the maximum value of y. So you put it in max underscore y, and then where that max underscore y is located, and you put it in the variable y underscore index. Okay, and it will give you that max y is 3, and then the index value is at y is equal to 3. Now I want to get the x value at that max. Okay, in this case, so that's why I put in, that's why I got the y index, so that I could get the value at x on that particular index. I want to make sure I have the correct coordinates. In this case, it's located at -1. Okay, so it's here, but it's kind of obvious. Okay, now what I want to do is I will plot that particular point. So I'll plot, if I'll just plot uh x value, sorry, x value, and then the value at y, and then make it uh, a circle and then color red. Sorry. Okay. As you can see, it highlighted the plot here. Okay. Now, I want to have a string. So this string is sprintf some value. Uh, so blank. So all this symbol division G. All this symbol I forgot. Is the maximum data point. Is the maximum data point. So I'm just creating a text here. And then that G will have that value of max Y. Okay. So I have now my string, whatever that string is. And then if I put text here, I'll text, where is that located? So I want it to be on the X value, but I want it to be higher by a little bit. Because if I put it on max Y, it will be overlapping here. So I'll just make sure it will be just above, plus around 0.5. And then what text will I use? I'll just use my string. Okay. And then I will have that value here. 3 is the maximum data point. Okay. If you want to add strings on the graph, this is how you do it. This is better compared to GTEX, in my opinion. Okay, now let us have the legend. The legend one, again, if you have multiple plots, so you want to know, uh, what what are you presenting with your graph. So that's why we have different legends. So the syntax is legend, and then the first line, whatever your first line is, and then what you want to put in it. And then the other type, and then what you want to put in it. Example. So I have here. So I have here two data. So as a sine and a cosine x. So let's say. So we know that the first one is the sine x, the second one is the cosine x. Okay. So we have plotted. And then I'll just uh post process the axis. So what we'll having here is uh I'm just changing so that we only have one cycle. So it's from 0 to 2 pi, and then make it bigger. So around minus 1.5 to 1.5, so that we can see it properly. Okay. And then I'll put a legend. So I know that the first one is the sine x and the second one is the cosine x. So it will give you the legend. Okay. Make sure that you are giving out the correct one, because for example, if you mistype here, so basically you are giving out the wrong information there. So that's why make sure you know which part of the legend you are trying to give out. We can also put some special text in our plot. So if you want the Greek letters, you can see before I've already done this. Okay, so alpha, beta, gamma. If you want to put it in the title, let's say title. I want to test out. This is uh, let's say sine of, let's say, theta. Theta. Okay. So I have a small theta. So in this case, this is the sine and cosine of theta. You can see it will automatically be change. Okay. So these are the different texts that you can put out there. Okay. If you want a circle, so circle normally is used for the degree symbol. Okay. If, for example, you want the degree symbol, testing of the degree symbol. So raise, so it will be exponent and then circle Celsius. So it should give you degree Celsius. If you, let's try this one. Yeah, if you want to uh, have the proper degree Celsius, yeah, it will give you that one. Okay. In latex, you are not allowed to do that circ and then C, but in MATLAB you are allowed. Okay. So there are the different texts that you can put out. If you want to change something out of your data or out of your figure, you can use the text interpreter. Okay. So for example, you want to make it a bold font, an italic font. Okay. I normally use this because I want to change the font. Okay. For example, here, let's change this. I want to plot sine cosine. Okay. Here, you can see X label is tau from 0 to pi. I want it to be font size 16. Okay. So I'll remove first the font size so that you'll see the difference. So it looks like that, right? So it looks like it. But if I raise the font size, it will become bigger. Okay. So same thing with the y label. See, it became font size 16. Also the same is with the title. Font size, let's say I don't want 16, maybe 24. Oh, 24. Okay. Say, let's go back again. I want it to be boldface. So just put in the BN. So it will become boldface. If you want to change the font, I normally do this. Since I am using these plots for my LaTeX, I'm always changing the interpreter into a text. If I do that, as you can see, the font will change. Sorry, PF. This will work with LaTeX. I need the correct uh, latex code, but it should be the latex code. Okay. As you can see, the font changed. Okay. It will match now my latex. So let's just remove that to would be proper. 0 to 2 pi. So as you can see, the font is quite different. Okay. I always use the interpreter LaTeX so to change everything. Actually, you can do it in the figure window, but I prefer, programmatically. Okay. Now let's talk about subplot. So here is a example of a subplot. Okay. Now, before we do subplot, so subplots, if you want, instead of hold on and hold off, because hold on and hold off, sometimes you don't want graphs overlapping, just overlapping, right? Because let's say one graph is also important, but you want it to be um, displayed separately. Okay. Now you can do that using the subplot command. In the subplot command, so think of your figure window as a matrix. In this case, so we have 2 by 2 matrix here. So what this is the row and this is the column. So the size of a matrix here is 2 by 2. That's how you know how to code it. So let's put in the data first for the square and all of those. Let's put in the data first before we plot it. Okay. So in order for you to do subplots, here this is a 2 by 2 matrix, right? Let's first do the subplot command. Subplot. So what's the size of a matrix? 2 by 2. And then the next one is where are you going to put it? So in subplot, the way you number your position is 1, 2, 3, 4. 1, 2, 3, 4. Okay. So the first position. So this is the first position. So if you do that, all of the plot command will go on that position. And as you can see, it will be there. Okay. If you do subplot 2 to 4, it's on the position 4. Okay. You will see a plot here. Sir, can we make 214, 21, let's say 211. So what we have there is 2 rows and 1 column. So what you will have is something like this. Okay? How about the other one? So since nothing overlap it will still remain in place. So let's say you make it 231. Okay, so you have 2 rows and then 1 column. How about 331? Okay? So it will divide it into 3 by 3. Let's say I put it in the 9th position. If I put that in the 9th position, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will overlap with this plot. So what will happen is it will remove that plot and then redraw on it. So let us flip the figure again. I want to display, what do I want to, I want to make this graph, circle square. So subplot, subplot 2 to 1, and then I want to plot the uh, circle, right? Circle. Y circle. And then what's the color? It's a green one. So green. You will have a circle graph there. So if you do axis equal, oh, so the axis is from -5 to 5, -5 to 5, and then -4 to 4. So let's change it. Don't forget the square brackets. Okay, so you have a circle here. Now we want the square on the other side, on the position 2. So that's position 2, and then plot x square, then y square. So that is okay. Let's have the what's the one? The triangle one. So again, subplot. So that's 1, 2, 3. So subplot 2, 2, 3. Okay. And then I want to plot x triangle, y triangle, and then what's the color? Blue. Blue. And that's a triangle. And then I want to plot everything else. I want to plot all of them in the position 2 to 4. Can we do that? Yes, actually you can do it. So you can just plot the circle, and then let's change the axis and hold. You can do hold on, and then let's plot the square and then the triangle. Okay, so that's how you use the subplot command. Any question? Any questions so far?
And so far, sir.
Okay, so that's how you you use very the basic line plotting. Okay, now aside from a line graph, we can represent two-dimensional data into different form. Okay, we can do scatter plot, bar graph, histogram, a star step, stem plot, plot with error bars, pie chart, area plot, and then complex plots. Okay, so let's have a short uh, 10-minute break and then we'll go straight with this. Okay. Are you still there? Hello.
Yes, boss. Hello po.
Okay. Now let us have some specialized to the plot. Yes, Mr. Makaraig.
Sure question lang po. Before po ulit tayo mag-start, ay gusto ko lang po sana yung concern kung kailan po kayo possible na mag-release ng approved na topics po para
Ah, yeah,
makapagsanda na rin po
probably it
kami.
will be this
Thank
week.
you po.
Okay.
Good question. Thank you po.
Okay. So any other question? Okay, now let us go with our specialized to the plot. So we have I'll be discussing here these plots. You'll see the how will they be used later on. Okay. So scatter plot. So let's say I have this plot. So basically this is I have here a sine wave with some random numbers, right? Now, if we try to plot it, plot xy. Oh, sorry. Fail if we try to plot it, as you can see, we can see the shape. However, it looks very noisy. Now, uh, sometimes we just don't need the data to be connected to another, to be connected by line. Oh, so that's why we use scatter plot. If we do that, okay, you can see all of the data plots, and then you can properly see the shape. Okay, sometimes we need only the data points, uh not all of them connected. As you can see here, we could visualize the sine wave more properly compared to the other one. So that's the scatter plot. Okay. Now, for this example, it's quite obvious, right? Because if we use plot, okay, we can still see the data, the sine wave, even though it's not that better. Now, the, since our x-axis here, as you can see, the x-axis ranges from 0 to 2 pi. Okay. Now, what if our data points in this case, our data points is x is random, and then we'll, we'll just have a sign version of that x. Okay. If we plot it, this is the problem with the line graph. Okay. Problem with the line graph is it will connect one point to the next and to the next and to the next. As you can see, it's not that clear. Okay. But if we just plot the data points, we can see the particular side shape. And also, it's also clear to us that most of the data points are in the middle here. See, most of the data points are here. Okay, some there are some data points here, some are here, but we can also see that most of the data points are in the middle. Okay, so if you have random, very random variables, sometimes it's better to plot it scattered using plots. Okay, now for bar graph, the bar graph, the syntax is bar xy. It's just the same as the plot command, but uh it will represent it differently. Okay, for example, here I have an assembly line number, so 1 to 7, and then so this is the score of the assembly line and the percentage pass. I want to see the line number versus the percentage. If we put it, so this is the bar graph. Okay, and the good thing about bar graph is we can easily visualize the differences. But the problem with bar graph is it could be easily manipulated, okay, with cherry picking. See, if we change the limit of y, the bar graph can easily be cherry picked. Okay, it seems like uh, line 6 is very much worse performing. Okay, actually, it's the worst performing, but it's not that worse. It's even worse if we make this 70. Seems like it's not performing at all. Okay, so that's for the bar graph. You can also use it to become a function. So bar, if you want to make the line style, bar xy, x and y axis. If you want to get the data, the x line data and the y line data of your bar graph, you can do it same thing as for bar xy. For example, here. Oh, no, not. So let's say you have a cluster data. So here is I have x here. So 1, 3, 4, and 6. And then y here is okay, 1, 3, 4, and 6. And then y is two pairs. If we plot in bar xy, what MATLAB will do here is, as you can see, this is 4, so it have 4 column. So it will think of it at that these are the two values representing them. If we plot it out, it will give you two graphs. Then you can see the data points of those two graphs. Okay. So these are the different variations of bar. So a stack bar, uh, let's just plot it out. So we have first one subplot 2 to 1. I want it to use bar y stack. So I'm going to just plot y and then use as okay, so it will stack the two plots together. Okay. Now if I put in 2 to 2, so what I will have here is bar x, y, and then I will make a separation of 0.5. Okay, as you can see, it has a fixed separation of it has a fixed width of 0.5 and a separation 0.5. Now, if I do bar A, if I do RH, it will give you horizontal graph. Okay? If you only want uh, one graph, if you only want a thin line and then there's no spacing, you just type -1. Okay? And then we can also do three-dimensional bar graph. So let's say I have another figure, bar 3 XY group. So bar 3 XY, and then I'll put it Y group. So as you can see, it will group it out, but it's giving you a three-dimensional bar graph. Okay, so that's the variation of bar. Now histogram. Histogram, on the other hand, you want to show how many occurrences do we have. So we have hist y, or his y, and then bin centers. Okay, so these are the different command. If you want to show the different occurrences, for example, this is very useful if you are doing measurement. So for example, you are designing 1,000, let's say 1,000 nuts and bolts. Okay, you are measuring the radius, or let's say the diameter, the inch diameter. Now you are measuring it 1,000 times. Most of the time, we want to see the number of occurrences of, let's say, the one that you're measuring is supposedly 3 millimeters, but you measure it 3.1, 2.99, 2.98. We want to know um how many measurements are outside the range of, let's say, the your valid range is 2.7 up to 3.3. Okay, you want to know how many of it is in, so you'll need histogram plot. Okay, so for example, I have here a number of this graph. Let's see, I have 5,000 data. In this case, I'm just making a very large data. So y is some data. So y is a very, very large data, 5,000. And then I want to, eh, I want to get the occurrences of y using the beans x. I want to get how many are those from 0.2 up to 10 at a separation of 0.4. I have 0.2, 0.6, and then 0.10. So I have uh, three beans, as you can see here. So we have there from 0.2, 0.1, most of the values are around, most of the number of occurrences are around this data. Obviously, because this is a logarithmic value. Okay, and then if you just put in the y label, so this will give you the histogram. Okay. Now, sometimes you want to plot the percentage instead of the number of counts. Okay. Sometimes you just don't want the number of counts. We only want how much of it do you want. So in this case, let's try getting some output argument. So here, You can see we have n is 1 by 25. Now I have how many? I have 25 beans. So n, let's see what's the value of n. So n is from uh so it has nine. The first bean has of course 891 times. The next one of course 721 times, 729 times, and so on and so forth. And then if you look at the centers, so the centers we defined it as point 2, point 4, and so on, point 6, point 8, see point 2, point 6. So these are the centers. If you use the bar graph, since we have the data from the histogram, we can use the bar graph. Basically, a histogram is just a bar graph also with additional pre-processing before. So in this case, what I want to do is I want to just convert it into percentage. So n divided by n, number of data points times 100. If you'll do that, you'll see you have here our data. Okay, so it's 18%, almost 18% is the largest one. Okay, now what's a stair step graph? Stair step graph basically is a line graph wherein you don't have a slope. Okay, so let's have stairs plot. So okay, so I have here x. X is from 0 to 20 and then 2 pi to 10. Okay, let's do some plots. I'd like to I'd like to show you how the stairs plot work. So stair stairs plot. This is a stairs plot. So as you can see, the stairs plot has a fix. Okay, it will not have it will connect 2 points, but it will have a zero slope. Okay, now let's try this one out. As you can see, your two x's don't have the same measurement here. Okay, so as you can see, this has a more precise steps while compared to this. Now, so here, let's say I want to plot the sine and cosines. So you'll see the difference between a stairs plot. As you can see, if we are using the plot command, it will just connect all the lines together. Okay. Now, let's have this. Subplot 223. See what was our plot there. You can see this is stairs of x1, x2, y2. So they connected them with each other since as you can see, so it's 1 to 9, 4 to 1, and then we connect another one here for our one. So basically, it just connects to the first point. Okay, that's why it's closed. Okay, let's try. If we put in the plot, you can see since this point, okay, are connected with each other, so you will see a straight line. But compared to here, you'll see the staircase plot. That's the difference between the staircase and line graph. Okay, so if you want to do the stairs plot using plot command, you can do this. Get the x, y, and y as value, and then just plot the stairs. Plot the x, s, and y as value. You basically have the plot command. What stairs is doing there is it's adding additional data points in between. So you'll have you can use the plot command. Okay. Stem plot on the other hand, this is used if you want to represent your data um, discretely. Okay, discrete. What do you mean by discrete? In signal processing, our data is discrete because they don't contain values in between. Compared with the line graph, for example, this one, this one. This is a line graph, right? From one point to another, or let's say this one, from one point to another, they contain data in between. But staircase plot or stem plot is used to denote data that does not exist. Okay, normally these are digital data. Okay, let us have example. So this is a stem plot of a sine wave. See, if basically this is a sine wave. If you use plot, you will have a sine wave. But here, what we are using is we discretize it. There is no data in between this point and this point, this point and this point, this point and this point, and so on and so forth. So that's the use of the stem plot. Okay. Sometimes you want it to be filled, so just put in fill. But this one is star. Okay. So actually it's not that good. We don't want that because it's a pentagon. Okay. This is how you represent it properly. Okay. Now, sometimes we want to see uncertainties or inaccuracy in some of our value. So here we can use error bar, x, y, and then error. So how do we compute for the error? Normally, error is our standard deviation. X and y is the mean. Okay. Example here. So the mean is this value. It's an exponential. It follows as exponential term, and then the standard deviation is this value. If we plot error bar, see, it will show you the error function. This is important for us to see what are the possible range of, let's say, example. Let's say the example we have before, the one you are measuring nuts and bolts, right? You can put in the error bar in between with your graph. If you want to just put the line, then put the error bar. You can see, oh, this is the range. This is the range when we are giving out 2. Okay, I will expect something from here. Okay, so that's error bar function. Pie chart on the other, you already know pie chart. So let's make a pie chart. You want a pie chart, so it will look like this. Okay, then you if you want to put some label into it, you can put it after. So here, instead of the percentage. If you want to explode one of it, so in this case, I will explode 1, 2, 3. The third one, SOC, personal borrowing. What happens is, if I put pi and then explode. The borrowing part will then be exploded or it will be removed out. Okay, as long as it's non zero. So for example, you want this to be 0.5. Explosion is here. Okay. If you want pi 3, it's okay. We can also do that. Basically, it's just a pie graph which is three-dimensional. You want area plot? Area plot means you are getting the area. You're plotting in an area. Okay, for example, here. We have sine x. So the area plot, it will give you a colored area from 0. Okay, so that's how you do area plot. Here, if you have this plot, so y 2.5, let's plot it. Area, you do that. See, but what I'm doing here is 1, uh, 1, and then 2. So from 1, so from 0 to 1, and then 2. The next one is 2, 1, 6. So the next data is from 1 to 3. So that's 2. And then the next data is, what's that? 1.5. So 3. Where is that? 0.5. Yeah. 1, 2, and then 0.5. The next one is, it will go from 2 and then plus 1. So it's 3 and then 0.6. So it will cover that area. So this is the area plot. Okay. Now, how do we work with complex data? Complex data is a representation if you have many changing frequencies in your data. Now, for example, here, I have here. So this is a complex data variable Z. But if we plot that, it will give you something like this. So it gives you from basically a circle. In this case, it's e raised to j pi. It's a circle, right? Now, here, I want to show the pole and zero of a transfer function. Why do we want to show a pole and zero of a transfer function? Actually, in control engineering, the poles and the zeros represent, okay, how your system will behave if you put it out. Let's say if you put some signal onto it. Now, in this case, I want to plot the zeros and the poles. Okay, in a complex domain. So in this case, I have zeros located at -8 and -4. And then I have a poles. Poles normally are positive, negative, are complex numbers. But it would be better if the poles are actually real. Okay? But most of the time, it's not real. And it comes in pairs. Okay? Here, I want to plot the poles. Okay? So I'm plotting the zeros first. It will be located here and here. Okay? And then let's hold it on. Hold on. And then I'll plot the next one. I'll plot the poles. I want it to be X. Hold off. Then I'll change the axis. I'll change the label. So x-axis is the real axis, y-axis is the imaginary axis. Okay. Now, what do I have here? So here is where the poles and zeros are located. So in this case, this is the zero, and these are the poles, zero, and this is the real axis. So as you can see, uh, we could not make anything about this. What is that? Okay. Actually, that's not how you want to see the poles and zeros. Okay. Normally, but we should look at it in the polar domain. But here we could see it that the zero is here. Zero. The zero is uh, located at -4 to 4. Okay, here. So it's located at -8 and 4. Why? Wait. But why is it my zeros? Sorry, there's a mistake. Be like this. Yeah, it's -4 to 8, and then hold on. Yeah, we can see it now. So these are the two zeros, and these are our poles. So from zero here, and then poles are here. Actually, uh, what if you are designing control systems, the pole should never be in the left side. Okay. Oh, on the right side, sorry. On the right side, and as you can see here, the poles are in the left side of the origin. Okay, but it's not very clear. Anyways, so if you want to use the plot command, now, there are several ways to represent uh, complex function. So here is a feather plot. So the feather plot, let's just demonstrate. The feather plot here is U is the x-axis component and V is the y-axis component. Or you can just real and then imaginary. Okay, let's try this one. This is our x theta, and then r is equal to sine theta. And then I want to convert that into polar to Cartesian. So I have U and then V. Okay. So U is some value. So basically it's the real number component, and V is some value. Then uh you call this the imaginary component. Now here I just want to convert U and V to its imaginary component. And then if I use a feather plot, I want to use feather, and then cyan. So this is the feather plot. What does the feather plot do? Basically, the feather plot gives you the vector diagram with respect to the x-axis. So as you can see here, so it will look like a field, okay? But it's two-dimensional. The length of the arrow shows you the magnitude and direction of your uh, feathers. Okay, so this is the feather plot. Now, if you want, so that's for the Cartesian system. If you want to use the polar coordinate system, we can use either a compass plot, a polar plot, or a rose plot. So a compass plot, so again, U and V is the command. U x component, real component, and then imaginary component, or just the entire z plane. So for example, here I have here an an imaginary number, and then I put a compass. So a compass plot, think of it as the feather plot, but you look at the uh, instead of putting it one after the other, you just place it in your in the polar coordinate system, and you can see the different uh, vector quantities. Okay, so if you see the feather plot, so let's plot the feather again. See, okay, now as you can see, this plot is just this plot, but you are looking directly at the zero. Okay, we are not interested in the time domain part here. So basically, if you look at zero here, okay, you're looking at the top here. So it's like this. So as you can see, this is the first one. This is the first. This is the zero data, zero, and then this is the 330, and then here. Okay, and you put all of the lines in the same on the same origin. Okay, so that's the feather plot. No, the compass plot. Now, for the polar plot, see, polar plot is just a line graph, but in the polar coordinate system. Okay, see, so this is the polar. So basically, you have a polar coordinate system, and then you have a line graph. So basically, it's the plot version in the polar coordinate system. Okay, so the rose plot, on the other hand, is something like this. Let's type it. And then if you do rose plot, it's like histogram, but in the polar coordinate system. If you want some function, you can just use fplot and easyplot. Okay, just try that one out. Okay, and then this fplot. Just try those different plot. Basically, this is the plot version of our GTEX. Okay. Questions so far?
Wala pa po, sir. Wala po sa akin, sir.
Okay, so if we don't have a question, I think I'll stop at today, and let's discuss 3D next meeting. Okay. Next meeting will be on 24, 26. Okay. So if you don't have any more question, we can now dismiss. Thank you very much.
Thank you po, sir.
Thank you po, sir.